Neutron stars are among the most extreme and violent objects in the universe. Born from the explosive death of massive stars, these ultra-dense remnants pack more than a sun's worth of mass into a sphere no larger than a city. Their gravity is so intense that it can crush atoms. Their magnetic fields are trillions of times stronger than Earth's, and their surfaces burn at millions of degrees. Unlike black holes, neutron stars don't have an event horizon, meaning if you were to fall toward one, you wouldn't simply vanish into darkness. Instead, your journey would be far more violent, faster, and unimaginably destructive. From extreme gravitational forces to deadly radiation and magnetic fields that can tear atoms apart, falling into a neutron star would be one of the most horrifying experiences possible in the cosmos. But what exactly would happen? Would you be stretched apart like in a black hole, or would you simply disintegrate before even reaching the surface? Could anything survive such a journey? To answer these questions, let's take a terrifying plunge into the deadliest stars in the universe. As you begin your fall toward a neutron star, the first thing you'd notice is the overwhelming pull of its gravity. Neutron stars are incredibly compact, packing up to 2 times the mass of the Sun into a sphere just 20 kilometers wide, which means their gravitational field is hundreds of billions of times stronger than Earth's. At first, you might feel like you're accelerating normally, much like falling toward a planet. But within milliseconds, things take a nightmarish turn. The force of gravity increases exponentially as you get closer, pulling you faster and faster. If you were falling feet first, the pull on your feet would be significantly stronger than the pull on your head. This difference in force, known as tidal gravity, would stretch your body violently in a process called spaghettification. However, unlike with a black hole, where spaghettification occurs near the event horizon, the neutron star's hard surface means you wouldn't have time to be stretched indefinitely. Instead, you would be accelerated to nearly a third of the speed of light before smashing into the surface. The entire fall would take less than a second, giving you virtually no time to react before your body meets the most extreme conditions in the universe. But what happens when you actually reach the surface? The answer is even more terrifying. Reaching the surface of a neutron star is not like landing on a solid planet or even crashing into a gas giant. The surface is an unimaginably dense, ultra-hard crust made of atomic nuclei packed together more tightly than anywhere else in the universe. The moment you collide with it, your body would be obliterated in an instant. At the speeds you're falling, nearly 100,000 kilometers per second, a third of the speed of light, the impact would release an energy explosion equivalent to a nuclear bomb, but on an atomic scale. Your atoms wouldn't just break apart. The sheer pressure would crush electrons into protons, forming more neutrons, effectively turning your body into the very material that makes up the star itself. The force of the impact is beyond human comprehension. On Earth, a person weighing 70 kilograms experiences about 700 newtons of force due to gravity. On a neutron star, the same person would weigh over 14 trillion kilograms, experiencing a gravitational force so powerful that even atomic structures collapse. No material known to science, no spaceship, no suit, no technology could survive such a landing. But gravity isn't the only danger. The neutron star is surrounded by extreme radiation, searing heat, and the most powerful magnetic fields in the universe, each of which presents its own horrifying way to destroy you. If the crushing gravity of a neutron star doesn't kill you first, its insane magnetic field certainly will. Some neutron stars, known as magnetars, have the most intense magnetic fields in the universe, up to a quadrillion times stronger than Earth's. These fields are so powerful that they can distort atoms, shred molecules, and even strip the very structure of matter apart from kilometers away. Long before you reach the surface, these forces would begin affecting you at the atomic level. Your body's atoms, normally spherical, would be stretched into thin, needle-like shapes as the magnetar's field forces electrons into tight spirals. This extreme magnetism would disrupt your nervous system, causing instant and violent nerve impulses, leading to complete neural failure before you even realize what's happening. Even more horrifying, these magnetic fields can literally tear electrons from your atoms, disintegrating your body from the inside out. At a certain distance, you would cease to exist as a solid structure, reduced to a stream of charged particles spiraling along invisible magnetic field lines. And if that weren't enough, magnetars are also known for releasing massive bursts of high-energy radiation, powerful enough to fry entire planets from thousands of kilometers away. A single flare from a magnetar could release more energy in a fraction of a second than the sun does in 100,000 years. If you somehow survived long enough to get close, you'd be bathed in lethal gamma rays and X-rays, obliterating your DNA and breaking your molecules apart. By this point, your body is no longer intact, and you are nothing more than a cloud of charged particles being violently twisted by gravity and magnetic forces. But let's imagine for a moment that some part of you, in some bizarre form, makes it even closer. What happens next? Extreme heat and radiation. If the neutron star's gravity and magnetic fields haven't already destroyed you, the sheer heat and radiation certainly will. The surface of a neutron star burns at an unimaginable 1 to 10 million degrees Celsius, far hotter than the core of our sun. This intense heat would vaporize anything long before it made contact. Even the strongest heat-resistant materials on Earth, like tungsten or graphene, wouldn't last a fraction of a second. But temperature isn't the only danger. Neutron stars are surrounded by lethal radiation. The immense gravitational compression of the star causes it to emit huge amounts of X-rays and gamma rays, flooding the surrounding space with deadly energy. Any spacecraft, spacesuit, or shielding technology we have today would be instantly fried. Your cells would be shattered by radiation damage, causing immediate and catastrophic molecular destruction. At this point, if you were somehow still intact, you'd be obliterated into a plasma of subatomic particles, a mix of stripped nuclei and free electrons swirling in a chaotic inferno. Even light itself struggles to escape from the intense pull of gravity, and time near the neutron star would begin to warp. From an outside observer's perspective, your fall would appear to slow down, your image stretching and fading as the extreme gravitational field distorts space-time itself. But let's take this nightmare scenario to its final conclusion. What happens if some part of you actually touches the neutron star's surface? Spaghettification or instant disintegration? If you somehow survived the extreme radiation, the unimaginable heat, and the devastating magnetic forces, the final stage of your journey would be the most violent yet: impact with the neutron star's surface. But unlike a black hole where spaghettification stretches you over time, a neutron star delivers an instant and absolute annihilation. The moment you touch the surface, the sheer density of the neutron star's crust, billions of times denser than lead, would crush every atom of your body. There is no chance of bouncing, breaking, or even leaving a crater. Instead, the impact would compress your atoms so violently that electrons would be forced into protons, converting into neutrons in a process called inverse beta decay. In other words, you wouldn't just die, you'd be transformed into part of the neutron star itself. Your body would merge into its dense structure, adding to the sea of degenerate neutron matter that makes up the star's crust. Atoms, as we know them, cannot exist under such conditions. You would cease to be a recognizable form of matter. No remains, no dust, not even a single molecule left intact. This process would happen so fast that from your perspective, it would be instantaneous. But to an outside observer, due to gravitational time dilation, your fall might appear to stretch out, slowing as you near the surface. However, this illusion wouldn't help you. You would already be gone, consumed by one of the most extreme objects in the universe. But does anything stand a chance of surviving such an encounter? Let's explore the theoretical possibilities. Could anything survive? Under the laws of known physics, no human spacecraft or material could survive falling into a neutron star. The overwhelming gravity, intense radiation, and mind-bending magnetic fields ensure that anything venturing too close is either vaporized, shredded at the atomic level, or crushed into neutron matter. However, in the realm of theoretical physics and science fiction, there are a few wild ideas that might offer a slim hope for survival. One possibility is the existence of exotic matter, a hypothetical form of matter that could resist extreme gravitational forces. Some theories suggest that quark stars, even denser than neutron stars, could contain strange matter, which might behave differently under intense pressure. If we could harness or create exotic particles, perhaps some form of ultra-resistant shielding could allow an object to endure these harsh conditions. Another theory involves space-time warping or wormholes. Some scientists speculate that the extreme density of neutron stars might distort space-time in unexpected ways, possibly forming a bridge to another region of the universe. If a neutron star contained a microscopic wormhole, it's conceivable that an object falling in could be transported elsewhere instead of being crushed. However, this remains purely speculative with no observational evidence. A more grounded but still highly speculative idea is the possibility of artificial shielding using advanced quantum physics. If future civilizations could manipulate quantum fields or use negative energy to counteract extreme gravitational forces, it might be possible to survive near a neutron star, though this is far beyond our current technological capabilities. For now, the reality remains that neutron stars are some of the most inhospitable, destructive and deadly places in the universe. Any attempt to reach one would end in instant annihilation, but as our understanding of physics evolves, who knows? The mysteries of neutron stars may one day lead to breakthroughs in space travel, extreme physics, or even the discovery of unknown forces in the cosmos. Neutron stars are cosmic monsters capable of destroying anything that dares to come too close. Their crushing gravity, mind-bending density and lethal magnetic fields make them far deadlier than even some black holes. If you were to fall into one, you wouldn't just die. You would cease to exist in any recognizable form, reduced to pure neutrons in an instant. Yet, despite their terrifying nature, neutron stars remain one of the most fascinating objects in the universe. Studying them helps us understand the limits of physics, the nature of extreme matter, and even the fundamental forces that shape our universe. And while no human will ever set foot on one, our telescopes and theories will continue to unlock their secrets, revealing the hidden wonders and unimaginable dangers of these stellar remnants.